All right, welcome everyone to today's webinar, Love at First Sight, How to Transform from Manual to Test Automation in 2019. Just some quick housekeeping items. This webinar will be recorded, so after today's session, we'll be able to email this out probably tomorrow or the next day. If you have any questions, please add them to the Q&A box and not the chat. It's just a lot easier to follow along. And then finally, we have some exit poll questions, so it'd be great if you could take this opportunity and answer them for us. All right, so let's get started. All right, so today, just a quick introduction. Myself, Dan Giordano, I run product marketing here at SmartBear, and then Elliot Landon is today our solutions engineer on TestComplete. So we'll be going through a live demo and kind of getting a look in action at the tool itself and what it can do from switching from manual to automated testing. All right, today's agenda: current state of testing, why we need test automation, what we should be automating, certainly not everything, and then some quick tips for a transition. We'll look at some challenges, and then again, hop into the tool. All right, first, we'll take a look at SmartBear. Quick introduction. SmartBear is synonymous with software quality across the entire SDLC, from planning and design to testing and monitoring. We were founded in 2009 with 11 global offices. We have over 6 million developers, testers, and operations professionals from 20,000 plus companies that rely on us to test, monitor, and make sure they're creating and delivering bug-free software. And then lastly, we have 11 open source tools now and growing as well, 5 freemium tools, so it's easy to get started. And we're building that community and giving back to the development and QA community continually. We have some great recognition from obviously the bigwig analysts, Gartner, Forrester, continually ranked highly in the Magic Quadrant and Forrester Wave. And more importantly for you, we create products and tools across the entire SDLC, from non-technical users and developers on the UI side and the backend side. Today, we'll be looking at our UI test automation tools, specifically TestComplete. We also have other tools like cross-browser testing, which can run Selenium and Appium in the cloud, Load Ninja, a performance UI testing tool, and then flagship testing tools on the API side as well with SOAP UI Pro and Ready API. All right, so let's look at the current state of testing. Based on our last state of testing report, SmartBear runs a huge state of testing report every year with over 3,000 respondents. And this year, overall of all test automation or testing in general, 20% of it is automated, which is incredibly low. And again, at the enterprise level, these things are difficult. But still in 2018, when we took this for there only to be 20% of testing at the automated level, we're certainly want to increase that. And that's really because traditional software delivery cycle predicates that. So code is written by developers. Some testing is usually done in this development silo by the engineers themselves, maybe automated unit tests, maybe a small portion of automated integration tests, and then maybe there's manual smoke testing. But pretty much after that portion, we're actually going to build the application itself. So usually QA, because they operating later in the cycle, they need that application to be there, all of its dependencies ready to go. So once that actually happens, now we can test. And most of that testing is done manually in this phase, and it's that more traditional QA phase. And the big thing here is slow feedback. So at best, we're getting feedback loops of maybe a day, maybe a couple of weeks if we're running in sprint cycles, or maybe the development will take 2 weeks to work on something, throw it over to another QA team. They'll go work on another feature set and wait for feedback to get back to them over a week. There's huge implications here. Not only is that really slow, but there's things like context switching. When a developer is working on something and there is an error on it, getting that error back a week later, I now have to go back into my code and see what I was doing. So this slow feedback is just really a drawback on software delivery. And that manual testing, what it looks like today is it's tedious, it's error prone, and it's time consuming. So tedious, a lot of the things that we're doing manual testing on, long form fill outs, maybe, again, long end-to-end things, they're tedious tasks that maybe should be automated in a reusable way. Also error prone. So as humans go through the aspect of manual testing, we'll look at some bright aspects actually of human interaction with the testing medium, but we are error prone ourselves. So reading test requirements and translating those to actually running through the manual test. There's things that the tester itself, we can mess up. We can mess up spelling. We can also not go through the steps the same exact way. They're just variables that we introduce as humans. And then lastly, it's time consuming. Going through just testing a web form as a human, clicking through each form or each entry field, it can take a while. Again, when you add up 2-minute tests and you have 2,000 of them, there's just going to be a finite amount of time that you'll need to get things done. And manual defect resolution is expensive. So when defects are caught late in the SDLC, so here in the more traditional QA phase, maybe we're doing manual integration tests, we're doing manual system end-to-end tests. Bugs are really expensive when they're caught here. This is the opposite almost of shift and left, which you'll see comparatively later on. But we're finding bugs in maybe a staging server, maybe in a QA server, or maybe even in production. And those bugs, based on various reports and industry analysts, they're wildly, again, you can see here, $1,500 for finding a bug in production, and that cost is near zero when found, maybe even in a feature requirement, let alone the code itself. Right, and the outcomes of doing software delivery, doing manual testing, we're going to have sporadic releases, slow feedback, which is the huge killer we talked about previously. An expensive dev process. We're going to be we're going to basically take up a lot of capital time, many hours go into it. And then ultimately, we're not going to have as high quality software as we would with lots of test automation. We're going to let bugs slip, and we're going to produce software that is buggy to our end user. And Agile is changing the game, right? None of these practices, none of this traditional way of doing anything can continue forward with the way that Agile and DevOps is transforming software delivery. So now, instead of having these confined periods of define, build, and release, and all done by their respective teams, we're now in this Agile release where we're defining, building, releasing on a quicker timeline. That doesn't mean we have less or we're not testing as much. It just means that we're going through this value chain quicker. We're doing smaller implementations so we can have smaller testing cycles while maintaining that same coverage. But you can see here, because of the pressure of the development and actually software delivery, we need to automate our testing to be able to pull it off in the small window. And you'll see here, automation is going to be that bridge that allows QA to not be that bottleneck, which currently it is in many transformations from waterfall to Agile, or waterfall to a real quick continuous delivery cycle. Automation is that key factor there to break QA being a bottleneck. And what should we automate in that QA phase? Well, we're going to talk about 5 tests here that are all prime candidates for actually automating with a tool like TestComplete. The first one is unit testing, right? And this one isn't particular to TestComplete itself because it's often done at the functional level. But unit testing, they should all be automated and run in a CI/CD system. So unit testing is often done in one-off batches by developers before the commit. Unit testing thrown in your CI/CD pipeline will make your testing and make your delivery that more robust. The next piece is integration testing. So we'll call this currently maybe API testing, often the way that systems are integrated today. Another great example of what we can automate. We can do that actually with tools in the SmartBear family like Ready API. And then end-to-end testing has really been historically the prime candidate for test automation. So you'll see here on the pyramid, We've talked about unit, we've talked about API. UI testing should be your smallest amount of testing in your general automated portfolio and automated suite. But historically, it's definitely been where we spend the most time in test automation. And that's often because these tests are long. You'll see examples that are real world that have form fill outs of 50 plus forms, have steps that go through an e-commerce flow that add hundreds of items to a cart and check out. These things all take a really long time compared to, let's say, an integration test that might just be a quick functional poke of an API. These end-to-end tests are prime candidates because of that length of time. Performance testing is our next candidate for really broad automation. And this is because performance testing often actually has automation built into it with spinning up of different load agents and different distributed load that can then measure the performance of a system. And then lastly, smoke tests. Smoke tests are those tests that test core functionality that often happen right before we go to a next stage or actually deploy to the public. But these smoke tests are awesome for automating because you can really focus on a small portion, let's say 5, 10 different tests that maybe log into your application and check out one item. But just to make sure that anything that was done regressively works going forward. And then also the processes around these activities. So let's not just think about testing itself and going through those steps. There's also things around it like environment creation, test setup and teardown with data, data creation itself. But there's many things, wiping the database. We can do all of these things with automated tools. A quick look at why we should automate. We'll just run through some of these factors that, again, TestComplete really knocks home when we'll go through the demo. The first is speed. We're going to be able to run through these tests a lot quicker, where I, as a human, may take 2 minutes to fill out a form. The machine at the browser level will be able to do that in maybe 15 seconds. So you're chopping off tremendous amounts of time in the micro, and that really makes a big impact in the macro when you look at build time. Next is reliability. Again, from a flakiness standpoint, these automated tests are going to be a lot more reliable. And that's because there's a human error, which is here as well, which we've talked about previously. We want to reduce that human error by using an automated test script. It's going to be the same exact test script every time we run it. And then there's a reusability factor as well. We might not actually look at it today, but on both sides of SmartBear, both on the UI side and the API side especially, you can reuse functional tests, Selenium tests, SOAP UI tests to actually run performance tests as well. And that'll, again, it cuts down on test creation time and lets you create a super team in your QA organization that can handle functional, security, performance testing, all from that one automated test script. And then lastly, it's really a necessity in the CI/CD world. So if you have CI/CD pipelines, manual steps definitely slow those down. So the ability to run your automated tests in a CI/CD pipeline will give you that feedback that developers need quickly. So why isn't every team automating everything then? Because it seems like it has all these awesome advantages. There are some real challenges to the aspect of automated testing. The first, again, these are based off not only the DevOps report, Dora, run by Dora, which if you've never read it is great, check it out, but also our state of testing report. But 46% of respondents said they lack the skills and experience that test automation requires, those resources that you need, those QA engineers, the programming skills. And the other 42%, or another 42%, said they don't have the right tools itself. So not only do they lack the right skill sets for maybe running test automation or creating those test automation scripts, but then they don't have the right tooling either set up in the CI/CD or to create the tests themselves. So why are huge barriers to actually getting all this set up? And TestComplete really solves these through 3 quick kind of wow moments here. The first is that every application is recognized using our object recognition with artificial intelligence. So TestComplete offers this really, really robust capability of testing desktop applications, mobile applications, and web applications that your tests are not going to fail based on changes, based on finicky things in the DOM. We really have this robust object recognition that compared to the rest of the market is really untouched. Next is we can build and maintain automated GUI tests faster than ever. Through our record and replay capabilities, even through our scripting capabilities, you're going to be able to get set up easily and quickly. It's going to be very similar as to the steps you use in a manual test case. And then we're just going to be able to replay those. Again, on your own machine, distributed in a CI/CD pipeline. All of it's really flexible in its execution. And then lastly, don't start from scratch here. Reuse your functional tests. We have broad integration capabilities and kind of ecosystem play. You can integrate unit testing, Selenium, or even SOAP UI tests on your API side, drive those through your TestComplete test, even share data back and forth between the back end and the front end, but it really allows you to kind of your super test as you run through your QA phase. And then, so what automating looks like with TestComplete is it's more interesting, right? You're not going to be doing these rigorous tasks over and over that you maybe encounter, those regression tests that you'd run every Friday after a build is released. Working on automation projects gives you more time to create more tests. So you're going to boost your test coverage as well. And then again, it's going to be much, much more accurate in your execution, not only in test creation from the test requirement, but also every single time you play. And then automating with SmartBear here, here's a nice graphical representation of shifting that testing left out of the traditional QA phase and moving more automated testing down into the development and testing with the CI/CD pipeline. You're going to prevent bugs at a much cheaper cost. So finding bugs by the developer in minutes after the actual mistake is made, rather than having a QA member find it 2 weeks later, log a bug report in Jira. These are all time-consuming activities that cost money to us in the end. Finding that bug upfront by running a nice regression suite that's made by TestComplete on every single code commit can really, really dampen the average cost of your defects. So is manual testing good for anything then? And this is, I want to leave you with this before we go into our demo, because manual testing is necessary. It's absolutely necessary going forward as systems get more complex as well. But there's a time and a place for it. The first is exploratory testing. So everything we do in test automation, everything we'll show you, it's simply preventing bugs, right? So all of this is based on maybe we found a bug, or we might think a bug is going to come up here, but we're actually not finding bugs with test automation. We're just preventing them from getting to production on each regression. Exploratory testing is a manual testing practice that requires human interaction. The second is user acceptance testing. Again, some of this can be automated, and we certainly do want to automate some of UAT. But there are some things that a product manager or someone in the business side will have to go through manually and make sure the application, make sure the scenario fits their business requirement. And then lastly, really the most human thing you can possibly do is usability testing. So testing by the users to actually ensure the app is easy to use, easy to walk through. That will hopefully never be replaced by robots, but there's definitely some automated factor to it, but definitely requires, again, that humanness, that the manual interaction with the tool itself. All right, so now I'm going to turn this over to Elliot, and we will go through actually some test cases and show you how to move from manual to automated with TestComplete itself. So I'm going to stop my share. Let you take over, Elliot.
Perfect. All right. Thanks so much, Dan. So what we'll do today is just go through a simple use case. Dan mentioned before that there is a time and a place for manual testing, and we'll actually see in this demo how we can record our manual actions and effectively take that manual's test case, but with the power of data-driven testing within TestComplete, we can attach a CSV file and reuse that test case over and over again, and then see how we can implement our time in a place where it's most needed by adjusting some of the name mapping properties or those properties that help TestComplete identify and interact with specific objects during the recording, and how we can adjust these properties so that we can data drive our tests and use this test case over and over again for many different use cases. So whenever we're automating a test, it's important to know what our end goal is. So for this demo, I just want to outline real quick what we'll be going through. I'll open up a web browser and I'll interact with SmartBear's own e-commerce demo application. So I'll launch this demo e-commerce store. I'll search for a specific product, and then I'll click on the resulting image. And at this point, I'll add the item to my cart and create a checkpoint to ensure that the subtotal displayed in the cart matches a intended total that I have in mind. The end goal of this entire process is to take this one recorded test of several actions, but reuse them over and over so I can search for different products and check those products' corresponding price points. All right, so with this in mind, we'll go ahead and get started within TestComplete's keyword test. Just so you know ahead of time, this is a blank keyword test. There is nothing in my name mapping. So you'll see all of the actions and elements that we're changing to adjust for our data-driven model. So I'll click append to test. At this point, TestComplete will minimize, and that powerful object engine recognition that Dan mentioned before is now at work. So TestComplete is actually creating the underlying code, and whenever I interact with an object on screen, it captures that object and doesn't rely on image-based testing. So this is great from a manual, at least an advantage over manual testing, because now with this object engine recognition at work, I can rerun this test case on different machines with different size screens and different resolutions. And because we're not confined to certain coordinate parameters interacting within the entire screen, I'm relying solely based on the underlying objects here. We can reuse this test case and then test on a variety of different environments as well. All right, so I'll search for a particular watch that I've had my eye on for a while, and I'll click the search button. At this point, I'm taken to, we'll call this the search page, because we can see that the word search is in the underlying URL. I'll interact with the object that shows up as a result of my search query. I'll click add to cart, and at this point, I'll add that checkpoint. We'll add this checkpoint just to check that the subtotal amount seen here matches my expected total. And this expected total for now will just be a hard-coded value of $24,110, excluding tax. All right, so at this time, TestComplete is just internalizing that code and producing how it sees it in our system memory. It maps that object to our name mapping repository that we'll see later on, and how it lists all of the objects that we interacted with during our recording. All right. So at this point, I'll just remove the item from my cart. And I might have brushed over it a little too quickly there, but during when we're editing the keyword test, we'll see what that checkpoint actually created and what we're testing for with that content text property. All right, so at this time, TestComplete is taking that underlying code and creating, essentially our manual test case, but it's translating it into keyword operations here. So remember, the overall goal of this test case is to modify and tell TestComplete how to interact and ultimately see various objects on the screen and adjust them so that no matter what object I search for in our Smart Store demo e-commerce application, I'll be able to obtain the image results, click on that image, go to the resulting product page, and create that object checkpoint and check the product's price. All right, so at this point, we have a set of actions, and what we'll do now is just add one more action. So instead of ending the recording by by removing the item from the cart, we'll just end the recording now by closing the browser altogether. All right, so first things first, we need to make sure before we even think about data driving and reusing this test case in other use cases, searching for other products and checking their price points, we need to make sure that it plays back for this specific test case. This makes sense. It's like the idea of dominoes. In order to ensure that the 10th domino will fall down, we first must ensure that it works for the first one, the first domino, and the first domino will fall and make the second domino fall as well. Then we can assume that it will continue falling until that 10th domino is hit. So here we'll rerun the test case and see the playback results associated with, again, just automating this chronograph watch search in our e-commerce application, and we'll ultimately see the objects that were recorded and how TestComplete can see and identify these objects. All right, so we see that green checkbox that associates all of our tests passed successfully. We see here that the object property checkpoint that I ran through a little quickly during the recording, but ultimately this object checkpoint is just checking using the content text property associated with that subtotal object, and we're hard coding the expected value of $24,000 and just ensuring that what's displayed on the UI corresponds with that expected value. Great, we've now successfully played back. We are ensuring that that second domino is falling. Now what we can do is adjust, we can adjust our name mapping or the list of objects that were recorded and adjust the properties or the elements that help TestComplete identify during playback. So remember, manual testing is a remarkably powerful item at our team's disposal, but the underlying time cost associated with it makes it a very expensive process. So the human eye can, and the human brain can make millions, if not billions of comparisons every second. So we have to somehow translate all of these comparisons and all of these identification properties to TestComplete so that if anything were to subtly change, TestComplete can interpret those changes and still run through the test cases that we've outlined earlier. So what I'll do is the following while we, before we interact with our object name mapping, I'll go back to the Smart Store and I'll pull up that watch once again. All right, so within the name mapping repository, I'll now expand the list of mapped objects, or the ones that were captured during the recording. And under the system object, I now see the browser. Just an overview of what we're doing here. We're just going to look at the properties used for TestComplete's identification purposes and see whenever we change the underlying object that we're searching for, which properties need to be adjusted so that we can further identify and ultimately interact with a different array of objects. And we can see the need for this. I should have prefaced this before going into the name mapping, but let's just see what were to happen and why we need to adjust the name mapping. So if I were to, instead of searching for a chronograph watch, the only thing that I'm going to change here is the product that I'm searching for. I'll click finish, and I'll run back the test. So this is just to show why we need to adjust the name mapping repository, why we need to change some of the properties that help TestComplete identify certain objects during our recorded keyword test. All right, so TestComplete should update and return a resulting error. And it's just because we'll see later on that there's some element on this screen that whenever I'm searching for a different product besides the chronograph watch is preventing me from further playback and getting results of my test case. So I'll return back to TestComplete, and we'll see here that what changed during this playback that was different from our original one. So we can do, so if this were if we wanted to just create another test case, just searching for AirPods now, we could use the intelligent fix, but our ultimate goal is to reuse this test case over and over, not only for one other product, but for as many products, which could be hundreds, even thousands within this demo e-commerce application. So now let's take a look at the name mapping, or the list of all the objects that were previously recorded. All right, so no matter, in here, the underlying browser is just identified by the object type browser. There's no specific name associated with it. This lets TestComplete create simple browser loops and ensure just by recording in one browser, we can still test in several others. So now let's look at the underlying pages and how they're identified. So we have our home page, and just to make this a little bit more user-friendly, I'll go ahead and rename this home page. And since this was used in our keyword test, we'll automatically update the keyword test for you based on any name changes that were made here. So this page corresponds with the search results for whatever I searched for, whether it be a chronograph watch or AirPods here. So I'll navigate back to a chronograph watch. So we'll notice something here. In TestComplete, one of the underlying properties that we use to identify this page is the URL. We'll notice here that in the, if we navigate back to Firefox, whatever I search for, be it a chronograph, a watch, any product, that search will be appended at the end of the URL here. What TestComplete was able to realize is that we are searching for something in our previous page, and on the home page, whenever we search for something, it resulted in the search results here. And TestComplete was able to wildcard this property. So we can see that no matter what object we search for now, we'll still be able to interact and highlight this object and make sure that TestComplete can play back against this. We can see this that this was automatically accounted for because whenever we replayed that last test case and searching for airy pods, we were able to get past this page and ultimately interact navigate away from the search result page and go to the product page. So clicking on the resulting image takes me to the product page. And now let's look into, after renaming this object, let's call it search page. All right. Lastly here, the product page. So whatever we're searching for or whatever item we click on, that item name is appended to the end of our homepage URL. What we need to do to account for this is the following. Whenever TestComplete is interacting with this particular element, and let's call this product page to be a little bit more specific, we need to change the URL and essentially tell TestComplete, no matter what item we click on, we still need you to be able to identify and interact with the various elements on the screen, be it the add to cart button and the remove link button. So what we can do here is the following. Let's click edit. And then we are shown the edit name mapping item window. On the left are the selected properties that TestComplete will use for identification and playback purposes. On the right are all of the properties TestComplete can see, and we can choose to include those by highlighting them and pressing the right arrow button. And we can also unselect certain items and exclude them from identification purposes by pressing the right arrow button here. Excuse me, the left arrow button will include those. The right arrow button will exclude the selected properties. Great. So what we need to do here is edit and modify the identification URL. And you may think, okay, just like we did in the search URL, let's put a asterisk at the very end. That would be a good idea, but remember, the asterisk acts as a wildcard. So no matter what is added on at the end, it will ultimately see that page as the product page. So this means if I simply were to add an asterisk at the very end, you'll remember that my search page includes the word search and then the asterisk, but that means that the search page would ultimately be seen as the products page. So what we can do is the following. Let's go into conditional mode. And here we can add conditions to not only ensure that certain properties equal our expected value, but also exclude certain values. So let's do the following. Let's ensure we can wildcard this value and ensure that the URL can be anything, any product name can be searched, or not searched, but clicked on. But now let's add a value, again, interacting with the URL, and exclude the search page. And we can do this by excluding the search page's URL that we identified previously. So we'll say does not equal. And the URL property or string value associated with the search page is this. So this is ensuring that whatever page is identified here, it is of type page. it can have anything appended onto the end, but it can't have the word search in the URL. So this will help provide some clarification in that the search page does not get confused, at least from TestComplete's automated perspective, from the product page. All right. So if you remember, during the playback of searching for a different product besides the chronograph watch, it failed on the product page step. And if we look at some of the other objects that we interacted with on that screen, first and foremost, expanding all of our objects down to the add cart level. And here we go. All right. So we can see that it failed because the add to cart button, TestComplete associated the underlying href link with it, and it only works for that initial chronograph watch item. What we can do here is we can either wildcard that element, or since we've included we know it's going to be of type link, we know that the word that the content text associated with that link will be add to cart. Let's just exclude this dynamic property and only rely on the static ones. So I'll highlight href. And what we can do now to ensure that just relying on the static properties works for identification purposes is highlight this object on screen. We can see that the add to cart button was highlighted in a red rectangle. And we'll click OK to save these changes. So the only other element that I interacted with on the screen is the remove cart element. So what we can do the only other two other elements. First, the subtotal, which we can see in this corner. And the subtotal is just named in a dynamic way. We'll just change the name, but we can see there's no other dynamic properties associated with this item. We'll call it subtotal here. And the only other element now is simply that remove link. We can see that there's another dynamic href that will change from time to time depending on what I search for. So let's edit this and we'll remove it altogether just so we're relying on static properties here. And as always, it's a good idea to highlight and make sure that TestComplete can see and interact with this object. Great. Now, the only other element that we want to ensure we can interact with is that page or that image element. So what we can see, at least just from looking at our keyword test here, is that the image item here was named based on a particular size. TestComplete does rely on object-based testing, and no matter what size our image is, it will rely on the proportional coordinates, so that if I were to click on the lower right-hand corner, if that image would be resized, it would click on the proportional coordinates associated just with that particular object, not relying on the image-based testing of the coordinates of the entire screen. But this, we can see here, if we're relying on the coordinates of the object, what if the object itself is a different object altogether? Like if we're searching for a novel, that image size isn't going to be 250, as we can see it was named after. So one thing that we may want to consider in order to not get that trying to click at an element that's outside the bounds of the underlying object, we can just tell TestComplete, no matter what object size or what object we're searching for, no matter what size the underlying image is that we're trying to interact with, let's always interact and click in the center of the resulting object. We can designate this interaction by using the default -1, -1. And this is TestComplete's default way of denoting to click in the center or interact with the center of the particular object. All right. So the last thing that I'll do here is, just to rename that particular element. So it's not based on the 250 JPEG size. I'll just call this the search page product image. And remember, any updates that we do here, any renaming or any property editing that we do here will be automatically reflected as we designate in this dialog window in our keyword test that we've created in TestComplete. Great. So now what we'll do is data drive. We can take all of these actions here and attach it to a CSV file. In this file, we'll designate a list of objects. We'll only do 4 for the purpose of this demo, but you can see the power of it and the power of reusing test cases, as we can take this single recorded use case and have it applied to many different product searches and checking that product's corresponding price. We'll select make a data loop. And this is where we can, interact and create a new, create a new webinar variable. And I used a CSV file. You have the option of specifying an Excel spreadsheet, another CSV file. You can even connect to a database on the back end and provide a specific search query. We'll just keep it simple here and use a previously created CSV file. All right. So this is what we'll do. We'll tell TestComplete how this file is delimited. We'll see a quick preview of what's contained within this file. And TestComplete can auto-detect the beginning and end of the file, but we can iterate through a specific set of rows if we need to. And this is where we take the previous actions that we recorded and we'll map them based on what we want to, what's contained within the columns of our CSV file. So whenever I search for AirPods or a chronograph watch in the Instasearch text box object, I'll replace that with my Instasearch text box column. Likewise, whenever I'm checking the $24,000 price tag, I'll replace that with the value column. Now, when I run this test, we'll see the results of not only the initial test case that we recorded, but all of the other product searches and product price checkpoints that were included in our CSV file. While this is playing back, does anybody have any questions? Please feel free to ask in the chat window if you have any. If not, we'll just wrap up as we see these last 2 elements that are being searched for. What I just want to point out is, what's important to keep in mind when automating your test cases. It all boils down to, breaking down our manual tests and those, specific conditions that would translate into object property checkpoints. We need to break down, those manual test cases and see what variables would occur if the slightest thing were to change, because all of these variables need to somehow be conveyed to TestComplete, whether it's the name mapping repository and changing the underlying elements that were mapped, or creating a data-driven test and inserting some other actions in our keyword test. All right, so we can see the results of all these test cases, and not only the initial checkpoint, but all other product checkpoints that were conducted from our CSV file.
All right, we have a question. How would you handle if multiple items showed up in the search results page?
So what I would do is I would first see, from a manual perspective, let's say, there must be some sort of object identifier. And, from a manual perspective, if this were to occur, how would you tell another tester what to do in this situation? Would you tell them, no matter what, interact with that first element that appears? If so, then I would include maybe an object identifier property that we saw in some of the name mapping elements earlier, or some sort of numbered property that corresponds with the position on the page with, where on the page of this first item that we ultimately want to select. Otherwise, if there's, specific text that we could draw from a CSV file, we can actually use some CSV values and use that in the name mapping property. So add some variability, but it ultimately depends on how you would tell, another tester or any other person, what your end goal would be to interact. So whether it's the first thing on the page or interact with an element that has specific text associated with it, it would just depend on the use case.
All right. Anything else here coming on? Feel free to ask in the Q&A. If not, I am going to thank Elliot for his demo today. And again, this is all recorded, so we'll be able to kick this back to you as soon as we process it and produce it. So probably tomorrow or the next day, be on the lookout for an email with this recording. Thanks so much, everyone, for joining us today, and enjoy the rest of your Wednesday.
Thanks so much.